Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Engineering Mechanics, subject code ME25C02. For the past lecture videos, we have completed part 1, part 2, part 3. We completed successfully. Today, we are going to see the last part of this unit 1. That is statics of particles. We will see one by one. Last class we have seen the vector approach also. Now we are going to see about some continuation of that same concept, forces in space, etc. Equilibrium of particle in space under the same unit, that is statics of particles. Now we can see the diagram. We have the force F that is acting along X, having inclination with the X axis, then F cos theta X. Same thing we can see along Y axis, we can write Fy equal to F cos theta Y. F is Z, vice versa, the same thing, F cos theta is Z. Then finally, then we can write F equal to Fxi, Fyj plus Fz k. Then again we can write what is Fx, we can just substitute F cos theta x. What is Fy? F cos theta y. What is Fz? F cos theta is Z. Finally, take the F as a common term outside. We will get F lambda. Lambda is nothing but unit vector along the line of action of force F, and theta s, theta y, sorry, cos theta x, comma cos theta y and cos theta z are the various angle that is acting along those coordinates. Direction of force is defined by the location of 2 points, that is M and N. M means in terms of x1, y1, z1, and the same thing we can write for N, that is x2, y2, z2. D is the vector that is joining M and N. What is D? dxi plus dyj plus dk, sorry, dzk. We can write in that form, the vector form. What is dx? Already we have seen in the last slide. That is dx is equal to nothing but x2 minus x1. I think in the part 3 video we have seen this, subtracting the coordinates. y2 minus y1, z2 minus z1 coming as dz. F equal to f lambda. What is lambda? In terms of lambda, what you are going to write means dxi minus dyj plus dzk. We are writing in the same manner. So now the next step is nothing but what is fx means, just multiply the f, take the f term inside the bracket, therefore you will get f dx by d, fy equal to f dy by d, fz is equal to f dz by d. Then one problem we are going to see in this, tension in the wire is 2500 Newton. Determine the various components of Fx, Fy and Fz of the force acting on the bolt at A. The angles Qx, Qy, Qz defining the direction of force. This is a sketch that is given. Now look on to the solution. Based on the relative locations of the point A and B, determine the unit vector pointing from A towards B. Apply the unit vector to determine the components of the force acting on A. Noting that the components of the unit vector are the direction cosines for the vector, calculate the corresponding angles. Now see, we can write, that is solution, you can look on to the right hand side. We can see that one by one, that is determine the unit vector pointing from A towards B. Where is our A means in the earth we are having clamped in that area, that is A, that is pivoted, that joint is pivoted, that is connected, the B is the upward point. What you are going to write means you can see, so A is far away from the X, right? Behind the value only. What you are taking the value from point A towards B only. Point A towards B. So origin point is here only. So what you are going to take means minus 40 I. So what is that? Minus 80 J, then minus 30 K. Then finally apply in the formula, taking square of all the components of the I, J, K. Then take the square root. What is lambda? AB vector by modulus of AB. That is the numerator value is the same thing what you wrote in the top, divided by 94.3. Again, if you are dividing that 40 by 90, sorry, 94.3, you will get minus 0.424 I minus 0.848 J minus 0.318 K. Then finally applying in the vector form, we are going to write, that is multiplying that value with the unit vector, that is 2500 we got now. That value we have to multiply. That is the important step. We got it, right? Kindly go through the steps. After multiplying, what we will get? Minus 1060I plus 2120J plus 795K. Now again, this problem, noting that the components of the unit vector are the direction cosines for the vector, calculate the corresponding angles. What you are getting means lambda is equal to cos theta x I plus cos theta y j plus cos theta z k. What you got in the previous one, just substitute the values. What is cos theta x, cos theta y, cos theta z? Just substitute and find the angles also. That is theta x. We can find the angles. That is 115.1. Theta y is 32 degree. Theta z 71.5 degree. So this problem is very important problem. This a bigger type question they will mostly ask in the university question. The cable is that forces AB equal to 100 Newton and AC is equal to 120 Newton on the ring at A as shown in figure below. Determine the magnitude of the resultant force acting at C. Now we can see A, B, C are attached to one point. Now in the right hand side of the video we can see, considering tension in the cable AB, force is directed from A to B. Force will be directed. Hence take the coordinates of A as x1, y1 and z1. Coordinates of B is x2, y2, z2. This kind of coordinates type you have seen in part 3 video also, as well as this video also I represented in starting of this video lecture. So now we have to take the coordinates. You have to locate all the coordinates. Where is our A point means that's 0. There is no value for x. 4 is there. Then again 0. Coordinates of B also 0, 0, 4. Then position vector of RAB vector. Just separate these two values, x2 minus x1I plus y2 minus y1j plus z2 minus z1k. Separate all the values, you will get the unit vector along AB vector is equal to RAB vector divided by R. The same thing you will get that value divided by square root of 4 square plus 4 square. The tension in the cable again TAB vector is equal to TAB lambda AB. This also we have seen in the previous slide. That 100, what is the tension value that is given? 100 it is given in the question. Just multiply with the lambda AB. Cable AC also the same procedure. We have to take the coordinates for A separately, coordinates of C separately, then position vector you have to do, separate those values, that is x2 minus x1 in that order, y2 minus y1j plus z2 minus z1. Then you will get 2i minus 4j plus 4k. Then applying unit vector along AC vector, lambda AC is equal to RAC vector by R. Simply use the simplification 2i minus 4j plus 4k. Then denominator part you will get, after applying square root you will get 6 is the value. Then tension in cable AC, that is TAC vector is equal to TAC into lambda AC is equal to 120 into that the previous expression what you got, that is 2i minus 4j plus 4k divided by 6. Finally you will get 40i minus 80j plus 80k. Then what is the resultant? We have to add these two. What they have asked in the question, the tension of that resultant they have asked, just we have to add and combine the and filter all the, gather all the I component y and k. Finally you will get 40i minus 150.72j plus 150.72k. Then upon take the square root, squaring of all the values and take the square root, you will get 216.87 Newton. That is magnitude of the resultant force. Again, in the above problem, calculate the angle of resultant force. How we are going to find out the angle? That is nothing but in the resultant what you are getting in the x component divided by the how much resultant magnitude of the resultant value. Just divide it and you will get the angle. Cos inverse you do. The same thing, cos inverse of ry by r, that is you will get 134.02 degree. Then theta z also same procedure. Cos inverse r z by r, that is cos inverse of 150.72 divided by 216.87, which is equal to 46.238 degree. Finally, how we are going to check the values means, take cos of that value and square it. Square all the values. Surely it will come as 1, otherwise 0.99 something. Approximately we can equate to 1. So thank you students. Kindly I referred these two references for preparing this content. Kindly go through these references. Thank you students. And also go through the video once again. Also go through the references and the problem what you have solved in this video. Try to solve it again and again. So we successfully completed unit 1 with 4 parts. So we'll meet in the next upcoming video for unit 2. Thank you students.